Thanks so much. So good evening. My name's David, and I'm the director of the Center for the Environment at the Museum of Science. Come visit us. We make 20-foot lightning bolts. We'd love to have you. Today, I'm not talking about storms, but instead heat, which is really the topic of my research. And I just wanted to say, I think this is great that y'all are getting together to do this. Really fits into the idea of collective science literacy, right? Like there's enough knowledge in this room of every way of knowing to tackle this problem. You just need to figure out how to do it in a way that's going to work for all the people that you know and the people that you serve in the work that you're doing. And the museum would love to be partners in that in whatever way we can support that. I've been asked to talk about extreme heat. And as I mentioned, I'm not from the Neponset River watershed, but I will say, maybe this will make you really not like me, but I ran a race here that is my favorite race I ever ran. It was the half of Quincy, probably shut down the streets one Saturday morning and you really grumbled about it, but running along Wollaston Beach was just like a really spiritual experience. It was beautiful to be part of that race. So love this part of the region. Heat is different, right? Heat is different because you can't see it the way that you can see sea level flooding, that comes from coastal flooding or riverine or inland flooding. And so it has different vibes to it. It's also unexpected here in New England, right? It's not something that people really have been worried about for a long time. And there's a lot of knowledge in this room. I just want to say the city of Boston has really been pioneers in showing that the building stock and the changes that are coming, heat is a concern for our region. A lot of people didn't think that 20 years ago, but it is. It's a big concern for our region. And it's a concern for a couple of reasons. One is infrastructural, right? So many of you have been experiencing changes that happen because of heat. When a plane can't take off in Phoenix anymore between 10 and 2, which happens regularly now because there's less lift, that affects and has cascading impacts across the country on our transportation. Many of you might know that the commuter rail was affected 4 or 5 times last year because of extreme heat effects that were different from what was happening on the Orange Line at the same time. And so this can affect your day. It can actually affect the way that bridges hold themselves together. It can affect sidewalks. It can affect streets. And the good news is we got smart people like y'all working on this, but it is a thing and we have to worry about it. Maybe not as many people realize that it's also a big impact for our human health, right? It affects our human health in a few ways. So believe it or not, extreme heat, even though we can't see it, is the biggest killer of any natural hazard in the United States every year. And as I keep saying, it's invisible, but it matters a lot. And this is from the last climate assessment. And then from the bottom is the one that we heard came out this week. Over 700 deaths per year, at least over the last 2-3 decades, and some people think over 1,000 deaths per year. And this is sort of on top of cumulative exposures from other problems that people may have and affecting the people who are most vulnerable to these things, right? Basically, the warmer it gets, the more deaths that we see from people who are hanging on in other ways. And heat is inherently not felt the same, right? It depends what neighborhood you're in. Depending where you live, your exposure to extreme heat is different now, and it's going to be different as the amount of heat we experience, the number of hot days that we experience per month and per year changes over the next 2-3 decades. And this is because of impacts that we have that both cool and warm our urban and suburban spaces. So this is from the National Climate Assessment, just came out last week or this week as we heard. And we know more and more about how the urban form of our built spaces through the geometry, from building height moving around, and urban canyon effects from the properties and colors of the materials that we use tend to trap heat, especially at night. So you get those hot times and the city's not giving up its heat to the atmosphere the way it does in other places. And then you end up with certain days where it doesn't get below 75 multiple days in a row. So you end up with these people who, maybe they have, other problems that are already affecting their cardiovascular health. And this can be the thing that just kind of puts them over the top and makes them very sick or makes them die. And we all know that urban heat islands are a thing, very well known, have been known for other than 50 years, and is true in our region. So this is actually from MAPC. They flew an airplane over, and this has been done with satellite data too, showing that the land surface temperature, we'll talk about different ways of assessing heat in a little while, can really vary by up to 60, 70, 80 degrees at the same time on a hot day, depending on what those urban spaces and the urban form is like. And we all have experienced this, right? You drive downtown and you know that it can be 6, 8, 10 degrees Fahrenheit different depending on what part of a community you're in. And so the people in those communities face not the same risks. And that's a lot of what I'm going to talk about. But first, I do want to say that the city of Boston and the areas around it are going to face a non-stationary and uncertain threat. So this is actually from our colleagues at Boston. This is from the Climate Ready Boston report from 2016. I'm originally from the Washington, D.C. area. I got here over 20 years ago, and now I'm experiencing a climate much more like the one I grew up with. And we don't know where we're going to land, right? One of the things that we heard very similar to what Nasser was talking about is that there's like a non-stationary and not totally understood threat about what we're going to face. And part of that is because we don't know where our emissions are going to hit. And part of it is there's things we just don't understand about the climate system. So we could end up, by 2070 with 25 days a year over 90 degrees, or we could end up with a couple of months over 90 degrees. And maybe even, that's an extreme scenario. I hope over 30 days over 100 degrees Fahrenheit. That's like the Birmingham, Alabama future that some people think we'll face. Hopefully we will not. But even in this picture from the left-hand side, you can see that not every place in the city of Boston is facing the same heat vulnerabilities right now. And this is very important as we plan for resilience. Why are some places cooler? What are things that we can do to keep every neighborhood cooler, and also especially do things in those neighborhoods that are already facing extreme heat risks and vulnerabilities? And that's where I'm going to transition a little bit to some work that I have done in urban heat island mapping here in Boston, 2 campaigns that we've done. I'm mostly going to focus on the campaign that we did in 2019 with our colleagues from the city of Boston, as well as Brookline and Cambridge, that produce data that is relevant for this watershed. But I'll also talk quickly about work that we did with the Mystic River Watershed Association, because I think that what we did with them might be a nice model for how you could do this across an entire watershed and help learn together about, how much bang you get for your buck with respect to cooling strategies that you can try in one community versus another. And this was kind of an interesting participatory science initiative that we did as part of a national project. So in 2019, we outfitted volunteer scientists, people like many of you, just regular people who you would meet in your community. They volunteered and gave up time driving. Some of them cycled, most of them drove around for an hour at different times of the day. So we've outfitted the vehicles with these things that are like car flags, and they have geospatially coded thermometers and data loggers in them, and people would drive around their neighborhood for an hour along transects, going through different land surface patterns to produce data. And we did this at 6 in the morning, 3 in the afternoon, and 7 at night to get a sense of what the urban heat island was temporally as the day progressed. And so what did we find? First of all, I want to say that this is part of a national campaign. It's been about 90 of these done, coordinated by the federal government from NOAA. If you go to heat.gov, you can learn about these. And we've done 2 of them here in coordinated by the Museum of Science with partners like the Mystic River Watershed Association and the municipalities. But also, there's been a couple of other ones. 2 happened this year. I think one of them happened on the South Coast. Like I think they mapped Brockton. And then I think Metro West did it too, because even in the suburbs, you're starting to notice people really worried about these urban heat island effects in their communities. So what did we find? So first of all, what you're looking on the left-hand side is what happened at 3 o'clock in the afternoon. That's the hottest time for an hour. So people drove around and made these squiggly lines, which are transects of the temperatures that were taken. This happens to have been in late July of 2019. And if you look at the legend, it kind of spoils the answer for you, which is that you can see that the coolest temperatures, the coolest place that we found was in the Chestnut Hill Reservoir in Brookline. And the hottest one was 102.6 degrees. So over 15 degrees different at the very same time, right? So at concurrent times with the same calibrated instruments, we found differences of 15 degrees. Someone is experiencing 87. The official reporting temperature, if you listen to Logan Airport, to weather, the Logan Airport temperature was 92. So you had 10 degrees hotter. And where was that hottest temperature? Well, you're actually sitting right there. I happen to have been driving one of the vehicle in a borrowed car with crummy air conditioning and got a sense of what Ashmont was experiencing that day because I was here. It was 102 and a half, 102.6 compared to 87. Think about the differences of what people are experiencing during this extreme heat event. And so it gives you a sense of what that is. And I'm not going to spend too much time. I am going to spend some time in the data, but if you want to play around with it yourself, and I'll send this around. You don't have to do it now, but there's a little QR code there. It has a story map where you can look at both some of our findings, how it connects with some of the stuff I'll talk about, but also it connects to a little game that we made where you can have a community conversation about resilience planning for heat based on Boston's heat resilience plan. We developed it with some of the colleagues of the folks that are in the room here. Happy to do that with you all or to send you those materials. So here is an interesting way I did it. I went around the map and I found the hottest places and I pulled them into Google Earth to see what did those places look like on the ground, because you can use Street View now, right? So not knowing anything about the Neponset River watershed, there are some places that I'll show you later where I was like, all right, let's find cool places and see what they look like. So this one, obviously, all of you know what it looks like. We're standing right there, and many of you probably take the T there. And there's a pattern for the hottest places, right? First of all, major roadways elevate temperature. A consistent height of buildings. If you vary the building height, it actually cools things because of the way it creates urban canyon effects and allows allows wind to permeate through. Being far away from water increases the temperature, and a lack of green space increases the temperature. Those are all things that are not unexpected, but we definitely saw in these data. So this is what that spot looks like, and a lack of shade is probably the most important parameter, right? Shade is really important in these things. So what's amazing is that the coolest place I could find, now I want to make clear this is not for your entire watershed, it's only the little sliver that overlapped with the work that we did, but the coolest place that I could find in our high-res temperature map, these are very high-res temperature maps, so you can really zoom in and get a sense of what the micro block level are and what you could do to cool a place on a block by block level, which is really what a lot of the resilience planners like y'all are trying to do. What can we do with this place that we know is hot for the resources that we have and the use cases that we know we want to preserve for whatever this community is doing? So what's amazing is less than a mile away, here's that spot in the Neponset River Reservation, and it was 88. So that's a huge difference. So is that 12 and a half degrees, or if I'm doing the math right in my head, a pretty big difference in what you're experiencing less than a mile or a mile or so away. And I don't have to tell you what that looks like because it sounds like all of you are out there frolicking in nature every weekend. This is another area I know very little about this, but so here 88 towards the bottom. I will say the further we get towards the end, the edge of our high-res temperature set, the less data we're working with. So it'd be wonderful to do something like this with y'all if you're interested. But 88 towards the bottom there near the Blue Hills. And then, here is a place that was kind of in between. Drag this in. This is a location in Quincy that was at 94 at the same time. So hotter than that reported temperature, the average temperature. And you can see, again, not much shade on a major roadway and having pretty far away from the water. And so these are things that we know we can do to cool our communities down. So this got a lot of attention. This is from the Climate Ready Boston update that happened later that year, talking a little bit about how these findings could be useful for the city to plan. And I think it informs some of the work that they did with the subsequent modeling that is in the heat resilience plan now. There's some really good use that we can do when we think about this very high resolution data and decisions that we make. So the city actually used our data in the work that the University of Vermont did for their spatial analysis lab, and they correlated changes in tree canopy against what they saw basically over 5 years against our temperatures. And not surprisingly, places that lost trees were hotter, places that gained trees were cooler. And this helps us understand that trees matter, and there are a number of very important, lessons that we can tell when trying to plan this. Unfortunately, we also have to think about the legacy of racism, right? Because the built spaces that we have are different because of policies that have been put in place. And I don't think I have to spend probably with this group too much time, because I'm guessing most of you spend a lot of time thinking about how to make our cities more equitable, but it does matter. So here is the social vulnerability index from the city of Boston. And I looked at our high temperature data and kind of compared it with places where you had more concentrations of people of color living in those places and low to no income. If you go to that thing I sent you, you can play around with all of MAPC's actually vulnerability indices, and we have that available, so you can look at it. But it does get to this, persisting legacy of racism and particularly redlining. So I do want to talk about that a little bit before we talk about things that we can do to cool it down. And the city of Boston has done this work within the city limits, and I know others have done it more regionally. So if anybody doesn't know, this is a policy that happened in the 1930s having to do with investment and disinvestment in certain communities. And unfortunately, those communities are the ones that are the hottest, the ones that were disinvested. And if you look at the words that were used in these policies, it's really quite odious and terrible. Things like infiltration of different groups, and they redlined certain neighborhoods, and we saw really compelling and statistically significant associations with which places which are hotter. So areas that were rated A and B, which were best or still desirable, were 1.9 degrees on average cooler than the places that were labeled as hazardous or definitely declining. So 2 degrees on average. You think about during a heat wave, you've got these communities that were, don't have as much parks, don't have as much water features, don't have as much investment in them. And so you see an average of 2 degrees. That's a big difference when you talk about average during these heat events. The good news is that when you look at, it's not good news, but auspicious news is that when you look not only at which ones are hotter, but things that are associated with the land use, there's stuff that can be done in these communities pretty quickly, I think. One of them is indeed planting trees. So you look at the areas that were redlined, and on average, we found 12% in the most redlined areas compared with 45 for mean tree cover. So that means we can start planting trees now. And of course, City of Boston has done that. Lots of communities are starting to do this. The results were more marked when I looked across the Mystic River watershed. And so that tells you that there's other places we can do this too. So planting trees is important. We know that there are important things to consider though for storm variability of vulnerabilities and other things too. Then there's some places we can't just plant trees, and we'll talk about that in my conclusion. But one thing we absolutely can do that came up earlier is impervious surface, right? So look at the difference between the areas that have been redlined with respect to impervious surface and the areas that had not. The best rated categories are about a third covered with impervious surface, and the areas here in the that were the hottest are 2/3 covered. And so porous pavement, other things that we can do, depaving, some of the things Somerville's doing can help us learn quickly how to, even if you have a certain street that had a really, really high vulnerability to heat, that's something that can be done pretty quickly. And there's a really interesting project, I'm sure many of you know about it, called Sea Heat from the Boston University, working with Green Roots and the Mystic River Watershed Association, among other partners, where they are depaving a block and trying to figure out what that does in terms of the amount of cooling that you get in that vacant lot that they depaved. So I really quickly want to talk about what you could do if you did this across an entire watershed, because we were lucky enough to do that with our colleagues from the Mystic River Watershed Association, like the project that this one, I think it was funded by one of these state municipal vulnerability preparedness grants. And I'm not going to dive too much into it. I'm just going to show you the outcome, which is that you can see the area that many people refer to as the lower Mystic, down where the river meets the ocean, had differences of up to 10 degrees or more, again, hotter, places like Chelsea, Everett, East Boston, and Winthrop, much hotter than the areas that you see, which are much more forested up in places like Lexington, Burlington, Woburn, and not a huge surprise, but there are some interesting things that we could do at the watershed level that I think you would be able to do too, because of the differences in land use and the many different municipalities that you're serving here in this group. And I want to point out a piece of optimism, although you got me sad, which is that here's Belle Isle Marsh. And these are not temperatures, these are changes in temperature in this, how much did it warm up? Belle Isle Marsh was amazing. You go to East Boston and it was one of the hottest locations that we found, but you went to Belle Isle Marsh, it was at least 7 degrees Fahrenheit cooler than a mile away in East Boston, and in some places up to 12 to 15 degrees cooler, depending on where in the marsh you are and where you're comparing it to a mile away. So that salt marsh, which is the natural state of where that area is, really did a wonderful job of cooling. Everybody knows that these salt marshes do a lot with flooding protection. I was surprised that they did that much with cooling. And you think about that, that's a much faster strategy than planting trees. And in some places, planting trees is not feasible. Salt marsh restoration can really make a difference. And that is, I think, exciting with the stipulation that we need to protect our salt marshes from sea level rise too. And you can look this up and find out what we found. So I'm not going to spend too much time, but it again got quite a bit of attention when we published the results. And we saw even more marked differences across these redlining categories when you look across a very wide variety of municipalities. The thing I wanted to point out is that there's lessons that can be learned among communities in a watershed. So what I did here is I looked, this is impervious surface, at what the entire area looks like. You can probably guess that's the Middlesex Fells right there. And those are the lower Middlesex Lakes, those areas that you see there. And the areas, the municipalities, I know this is hard to see, that experience temperatures of over 94 degrees, all of them were the ones that had the highest impervious surface percentage. And so that really helps you understand that these communities have commonalities that can work together and maybe try out different resilience strategies, figure out what works, and then the knowledge can be shared from one community to another. This is also true for trees. And unfortunately, it's kind of the same map. And not surprising when you think about the resources and different land use from places like Lexington versus something like Everett or Charlestown. I do want to end with a piece of inspiration, which is that smart people in our area are doing really good things about heat. This is a place where innovation is happening. The city of Boston is part of this. This is Fenway Park. Many of you know now that there's a green roof on top of Fenway Park, and it's not just marketing. They did it where they did it, from what I understand, because it was over the kitchen. And there are people working in those kitchens on hot days, and this reduces their cooling bill, but it also helps with the people that are inside while we're all sitting out at the ball game. And it makes a big difference. And California and now North Carolina have done these heat mapping experiments and have done different things, either painting an entire section of a roadway right or mixing in small amounts of light pavement that can cool down sections so you don't even know the difference. And it's not drastic for somebody who's standing on the side of the highway, so they don't get blasted with a array of air. But at the same time, it can make a difference at a community level. So cooling the city is one structure. Another strategy. Another one is these protecting the infrastructures, because we know that there are some places that are challenged during these heat waves. Everybody goes to the same place. They turn up the air conditioning. They go to the movie theater. And when these kind of backup systems and electrical connectivity things fail, that's when you really start to have problems. And so a lot of the green infrastructure work that's being done by the city and the other municipalities is really quite inspirational and important, and other cities are learning from it. The final thing I want to say is that I think that connectedness is so important. So you all are doing a great job by getting together and thinking about this. This point of social connectedness is so important. We know that cooling centers are definitely going to be something, and hopefully they'll be more like resilience hubs where they actually serve the needs of the people in the community, the 352 days we don't need them for emergency management. But what we do really need, I think, is this idea of knowing where your neighbors are and what they need, right? Because the meteorologist is telling you, find out about your elderly neighbor or the person who you really can't just text to find out. This is really where I think a lot of the public health ramifications happen. So I'm going to stop there. I'm happy to answer any questions if you have, and I hope we can be helpful to you as you do this work.
So I think we've got maybe a minute or two for questions, if there's any.
Yeah, please. I was going to bring up about the green roofs that you just did, because you said, there are many areas where trees, they're not feasible. So you look at Dorchester, South East Boston, Chelsea, even downtown. There are many places where the trees are not feasible. But I don't see any initiative like the solar panel one, you get a tax discount for the green roofs. That's something that should be pushed.
I don't know what the incentives are for green roofs. I'm sure there's knowledge in this room about it. I will say that there absolutely are programs from the federal government that are making those experiments work better, as well as white roofs, which is, not probably something you want to do at your house, but matters a lot at that warehouse, at that Walmart, like those places, they can make a big difference. One thing I do know that the state, through the MVP project, is incentivizing is, where you have these really large heat sinks from parking lots. There's work that can be done with both, stormwater adaptation and the porous pavement that happens and things like that. I also want to say that roofs are one strategy, but there's also stuff that's being done on the ground, and there's some really inspiring stuff that isn't quite as sexy as like transforming an entire building, but it's like knowing where to put a water feature, or an entire row of slow vegetation. It looks like bushes to us, right? But it actually can make a pretty big difference if you have this high-res data. You really need the block level data, and Boston's got a fantastic model that Sasaki did for them that might be more instructive actually than what I showed at this point. But knowing really not just what the community has as a neighborhood level, but really where in this community are we finding those hotspots? There's a lot of knowledge of the people that live in the community that can help inform that work.
All right, great.